Buongiorno, tutorini. It's Tutor Pat with another quick hit. This one about the 6 exponent rules. Let's get to it. So there are 6 rules governing exponents, particularly when I'm multiplying, dividing them, and plus a special bonus rule. But before I get into those, I just want to define very quickly what an exponent is. An exponent of a number just says how many times to use that particular number in multiplication. So if I have 2 raised to the third, that 3, that is an exponent, that tiny superscript above the larger number. That is an instruction telling me to take this 2 and multiply it a 1, a 2, a 3 times. So 2 times 2 times 2 is 8. So 2 to the third power, to the third, 3 being the exponent, is equal to 8. So that's what an exponent is. Now, before we can jump into the 6 exponent rules, we have to set 2 ground rules or conditions. The first one is when we use exponents in operations, that's multiplication, division, we have to make sure that our bases are the same. The base, as a reminder, is this big number here. Okay, so all the exponential operations I will be doing, the multiplication, the division, I will have to make sure that the bases are the same or it will not work. These rules will not apply. The second condition is that we always want to make sure, especially when we're working in the SAT and ACT, that the base is the lowest it possibly can be. So bases are the same, and bases are the lowest common denominator. So are the lowest they can be. For example, just move this down here for a second. If I had 2 to the third times 8 to the second, okay, I would not try, and I know that the bases have to be the same, right? So I would not try to make this into 8. That would be too complicated. Instead, I would try to make both of them into what we call base 2. So I keep the first one the same, which would be 2 to the third. And then that second term, we know that 8, from this up here, 8 is the same as 2 to the third. And then that would be squared. You see how I've substituted this base 2 in for 8. And then I kept that square over here outside the parentheses. So this, we'll see when we do the rules, is going to be 2 to the third times 2 to the sixth, which is going to be 2 to the ninth. Okay, so our 2 conditions have to be met. Our bases are the same, and bases are the lowest they can be. Okay, now we get to the rules, which I've already briefly previewed in that example. The first rule is if I'm multiplying like bases, for example, 2 to the third times 2 to the sixth, I add the exponents 2 to the ninth, right? So we'll do 2 to the fifth multiplied by 2 squared is going to equal 2 to the seventh. So when I'm multiplying my bases, multiply bases, I add the exponents. That's the first rule. The second rule is when I'm dividing my bases, I subtract my exponents. So when I divide the bases, I subtract the exponents. Coolio. Now our third rule is when I have a power raised to another power, I multiply. We actually saw an example of that when I was illustrating previous concept right here, right? So we substituted 2 to the third for 8, but notice that's still squared over here. So it's 2 to the third squared. So when I raise a power to another power, I multiply the exponents. Raise, we'll make that red for consistency's sake. Raise one power to another. I multiply. Fascinating, exciting, thrilling. On to Rule 4. Rule 4 says that if I have a negative exponent, let's say it's a negative third, negative cube, I can rationalize that by writing as 1 over x to the cube. I'll give an example. So if I have 2 to the negative third, that's the same as 1 over 2 to the third, or 1 over 8. So I rationalize a negative exponent by writing it as the reciprocal of a fraction. My next rule says that if I have a fractional exponent, let's say I'm raising x to the 2/3, well, that's going to become a root. And whatever is in the denominator of my exponential fraction becomes the type of root I take. So this would be a cube root. And then whatever is in the numerator is going to follow with the base under the radical sign. So x to the 2/3 would be the cube root of x squared. Or more often we see something like, let's say, 9 raised to the 1/2 power would be the same as the square root of 9 to the 1st. So when we take something to the 1/2 power, we are essentially just taking its square root. So again, when I have a fractional exponent, I make sure that whatever is in the denominator of my fraction becomes which root I take, and whatever is in the numerator of the fraction follows with the base under the radical sign. Just one more example, because that's a little wacky. So we had, let's say we had 7 to the 2/5 power. That would be equal to the 5th root of 7 squared. All right, our 6th and final rule, which is if I take any number and I raise it to the 0 power, it doesn't matter what number it is, it's always going to be equal to, anybody, any guesses? 1. So any number raised to the 0 power is always going to equal 1. So those are our 6 exponent rules, which almost always in either the SAT or the ACT are going to be tested with regularity and comprehensiveness, meaning they're going to go through every single one, make sure you know it. Sometimes in the same problem. But, because we care about you here at Mighty Prep, we have a bonus! A bonus rule. Simmer down now. It's coming at you. Rule number 7, our bonus, which is if I take -1 and I raise it to any even power, it's going to be equal to +1. But if I take -1 and I raise it to any odd power, it's going to be equal to -1. So let's see how that is. So if I take -1 and I raise it to 4, right, which would be an even power, that would be -1 times -1 times -1 times -1. -1 times -1 is +1. -1 times -1 is +1. +1 times +1 is 1. So I see that when I raise it to a even integer, it is going to give me +1. But if I take -1 and I raise it to an odd integer, in this case the noble number 3, we see that it would be -1 times -1 times -1. -1 times -1 is +1, but +1 times -1 is -1. So again, that rule is, if I take -1 and I raise it to an even integer, 2, 4, 6, 8, 10. That's going to give me positive 1. But if I take negative 1 and I raise it to an odd integer, 1, 3, 5, 7, 9, it's going to give me negative 1 again. And that is your bonus rule.